In this video, we're going to be looking at balancing redox equations given a acidic or basic medium in water. So again, we assume that the solvent is water here. So we dissolve, or we don't dissolve, we put this in an aqueous environment. So you have a little flask here, and it's filled with water, and you put the phosphorus and the copper in there. And what's going to happen is it forms these two compounds here, H2PO4 with a negative charge and a reduced copper metal. So you might be looking at this and you're saying, how did these H's get in here? How did these oxygens get in here? Well, these two elements are, and specifically we'll see phosphorus, is reacting with water in an acidic medium to produce these compounds, H2PO4 minus, and help copper get reduced. If we didn't have water, this reaction wouldn't really be possible. So let's go through here on how we go about balancing these, right? We don't have any forms of hydrogen sources or oxygen sources, so we're going to see how we do that. But the first step of any problem that you'll see is draw half reactions. So pair these up and pair these up. Okay, so it simply goes phosphorus into H2PO4 minus. Okay, this is your first redox half reaction. Okay, and then on the other side, you have the copper 2 plus into copper. Okie dokie, so we have our two reactions spelled out here. Now we have to balance with water where necessary. So notice here we have phosphorus just turning into H2PO4 minus. So we have to make it so we're reacting the phosphorus with some form of water to allow that to occur. So what happens is phosphorus, and notice how we have 4 O's and H2O only has 1 O, so we'll actually put 4 H's. So 4 H2O plus phosphorus is going to yield H2PO4 minus. Now notice here that we have some H's here. We have 2 H's, and over here we have 8 H's. So we need to add, and because we're in an acidic environment, we can add hydrogen ions to the mixture. So we want to add 6 hydrogen ions. So that's going to be 6H, right? Okie dokie. And another important thing here is notice we have a negative charge. We also need to add electrons, right? So here, notice how we have 6 H's and a minus charge. The overall charge on this side is going to be 5 plus, and on this side it's simply 0. So to balance out the charge, to make it 0 and 0, we're going to add 5 electrons onto this side. Okay, so this is a completely balanced half reaction. Now we have to balance the other side. Okay, so Cu2 plus to copper. Okay, we're going to need to add some electrons to make both sides 0. So we're going to go copper 2 plus 2 electrons is going to yield copper. Okay, now that these are balanced, we now have to balance the overall equation. So how can we do that? Well, my number one tip is, okay, look at these electrons here. Make them the least common multiple, right? So that would be 10, right? So 5 times 2 is 10. 2 times 5 is 10. So we want to keep it 10 here. So to make electrons 10, we have to multiply this equation by 5. So it's 5 copper, 2 plus ions plus 10 electrons will yield 5 coppers. Okay, so we have that. And then we have this equation here, which we will just multiply by 2 to make our electrons 10. So we have 8H2O plus 2 phosphoruses is going to yield 2H2PO4 minus plus 12H plus 10 electrons. Okay, now couple the two together. See what happens. So we'll actually write it out in a different way. I'll bring this over here and we'll add them together. So Cu2 plus 10 electrons is going to yield 5 copper ions. Notice that the electrons cancel. It's on this side and on the other side, so they just drop right out. And when we add these together, we get 8H2O plus 2 phosphorus plus 5 copper ions is going to yield 2H2PO4 minus plus 12H plus Cu plus 5 copper. Okay, so that's the overall balanced equation. Now I want to look at, okay, what if you have a basic medium? So let's assume that we have manganese tetraoxide with a -1 charge plus C2O4 2 minus is going to react in a basic aqueous medium, and it's going to produce manganese dioxide and carbon dioxide. So we're asked here to balance this equation. So how do we go about it in a basic medium? Well, like we said, we want to split up our reaction into 2 half reactions. So we'll actually just start with manganese. Alright, so we have the manganese is going from negative to this. And notice that we lose 2 oxygens just magically, it feels. And we can't just double this because then we won't have the right number of atoms of manganese. So what we want to do is add hydroxide. And so we can do that there by adding 2 OH. Right, because this is in a basic medium, we can add hydroxide molecules. Notice that our oxygens are now balanced, but our hydrogens are not. So we need to add water onto this side. So we'll go ahead and do that. And we want to add, let's just say 1 molecule of water. Right, this is how I would kind of work through this problem. Notice our hydrogens are balanced, but now our oxygens are not balanced. So there's a problem here with the H2O and these hydrogens here. Not wanting to balance. So we have to keep upping this number until we can fully balance both sides. So here we have 4 H's, so this would be 2 H2O. Okay, so notice we have 6 oxygens. Over here we have 6 oxygens. Okay, and I just randomly guessed 4. It seems to be working out though. 4 H's and 4 H's. So I know that we're balanced on the atomic scale. Now are we balanced with the charges? Well, you would say no, right? Because our manganese tetraoxide with the -1 charge is only 1 negative. So we'll say that there's a negative here and nothing else. Here we have 4 hydroxides, which all have a negative charge. So this is 4 negatives. So we have to add electrons onto this side by saying, okay, well, if I add 3 electrons, then our charge is conserved, right? We go from 4 to 4, okay? A charge of 4 to a charge of 4, that's balanced, and that obeys the redox laws. Okay, now let's balance our CO2 reaction. So we have C2O4 with a 2 minus charge going to CO2. Okay, this one's quite easy. Notice we just have 2 minus, so what we'll do is we'll add 2 electrons to conserve the charge, so we go from -2 to -2. Quite simple. Okay, so now that we have that there, what we can do is we have to couple these reactions by making the amount of electrons cancel. I see a 3, I see a 2, they both share that common factor of 6. So let's go ahead and do that there. So we're gonna say that 6 electrons plus, and we're gonna double our amount of water, so that's gonna be 4 H2O plus 2 manganese tetroxide times 2 manganese dioxide plus 8 OH. That's going to yield, and here we have to multiply by 3, not chromium, carbon. And we need 3 here, and it's going to react to make 3 CO2, and that's going to give us 6 electrons. So our electrons cancel. Okay, and now we need to do, we just add the 2 together, 4 H2O plus 2 manganese tetroxide plus 3 C2O4, 2 minus, is going to yield 2 manganese dioxide plus 3 carbon dioxide plus 8 OH. Okay, so that's the full equation there. I hope you guys enjoyed this episode. This was on redox and balancing redox equations in acidic or basic mediums. These are probably some of the hardest balancing equations you'll ever come by in your chemistry career. Hope you have a wonderful day.